Alright, our second in-class exercise that works in this chapter, number 18, we're going to look at these mechanisms a little bit differently. So basically, in each of these cases, what's wrong with the mechanism the way that it's given? Every one of these mechanisms is drawn incorrectly. So how do you fix them? What needs to be done to fix them? And so one of the things that would be useful to do in each case is to identify the nucleophile as well as the electrophile. Here, the nucleophile is the alkene. Bromine is the electrophile. So what's wrong here? Well, the arrow is going in the wrong direction. Same thing in the second example. Hydroxide is the nucleophile. The alkyl halide is the electrophile. And so we need to draw the arrow going in the correct direction. How about our third example? So we have the alkene as the nucleophile, and the hydrogen is the electrophile. So all of that's correct. And while ultimately the structure that's drawn here is the correct final product, it's the process to get there that's not correct. If this mechanism takes place the way that it's drawn, what will end up forming is a cyclohexane ring where those pi electrons have attached to hydrogen and we form a carbocation. In order to get to what was shown, we then have to do the second step of the mechanism where the bromine attacks the carbocation. And finally, the fourth of these is probably the most difficult on this page, because we have a nucleophile, the alkene. We have it attacking an electrophile, H+. So all of that's good. What's wrong though? Well, unlike the other alkenes we've worked with so far, this alkene is not symmetric. And so the hydrogen could end up on this carbon, which would mean we get a plus charge here, or we could get the reverse. Hydrogen ends up out here, and the plus charge ends up here. Which one do you like better? Personally, I like this one better, which you'll notice is not the product that's drawn here. Why do I like that one better? Well, the cation here is secondary. This gives us a better tertiary cation. And so that more stable carbocation is more easily formed and is the correct product or correct intermediate here.